To all the boys and girls out here, I would like to tell you all, never forget that we are our own competition. We should be competitive within ourselves. You realize your potential and believe in yourself. If you don't believe in yourself, how can everyone around you is going to believe in you? Start believing in yourself, and if you want to do something up, sharpen the talent that you have and polish the things that you are weak in. No one is perfect. It's practice, perseverance, and consistency makes a person a better version of who you were today. So, today's topic is on sets and relations, and this is related to MFCS, DMS, and DMGT. Now, we are going to discuss few important questions which are repeatedly asked in the question paper, and the solutions are given so clearly and vividly. Please do follow these videos, and please go to the playlist. So many videos are uploaded for your practice, and please, if you really like, share it with your friends, siblings, and whomever you like the most. So here the problems are: if A comma B comma C are any three sets, then prove that A union B minus C is equal to A union B. And next one, A minus B union C is equal to, this is A minus B, intersection, this is A minus C. And the next thing is A union B minus C is equal to A union B minus C minus A. So here there is an important difference identity. Just I am going to tell you everyone, that is A minus B is nothing but this is A intersection B dash. So this is the most important formula, that is A minus B is equal to A intersection B dash, and most of the problems are based on this formula. See here, the first thing is, the first question is, we have to show that A union B minus C is equal to A union B. See, in this B minus A is there. There is a difference formula here. So, in the solution, I am going to write, this is A union. So, what is B minus A? A intersection B dash. So, in place of this, I am writing B intersection A dash. And now see, if you watch this one, so I am using the distributive law. So, A is distributed to B as well as B dash. And now, for the distribution law, this will be A union B intersection, that is A union A dash. See here, A union A dash. A union A dash is the universal set, that is A union B intersection, this is a universal set. See here, the intersection point between these two sets, A union B and this universal set. So the common elements among these two is A union B, and therefore we got A union B. So this is how we got A union B from the RHS side. So I have taken A union B minus C, and I have applied the formula of A minus B is equal to, see here, this is A intersection B dash formula I have applied in this bracket. And next one, here is the distributive law. So after distributive law, see here, this is A union A dash is nothing but the universal set. So these are all the properties which I have given in my previous video. And see here, the intersection between A union B intersection U is nothing but A union B. And therefore we got the final answer as A union B minus C we have started. That is A union B minus A is equal to, this is A union B. So this is how we got the first solution using these three properties. One is the difference formula, one is the distributive law, and one is A union A dash is equal to a universal set. And the next question here is A minus B union C is equal to A minus B intersection A minus C. So in this, first of all, I am taking the LHS part. So if I take an LHS part in the solution, see here, LHS. So if I take LHS, this will be A minus B union C. So A minus B. So if it is A and if you consider this as B, so what is the difference formula? A minus B is equal to, this is A intersection B dash. So if I apply that one, so this will be A intersection. So this is B dash. Clear? So according to the De Morgan's law, according to the De Morgan's law, we have A union B whole complement is equal to, if you want to share this complement to each and every set here, then this union will become intersection. So if I apply this formula here, then this will be A intersection. So this will be B complement intersection. This is C complement. And therefore, this is A intersection B complement intersection. This is C complement. So here we got the answer like this. And see, if I take the RHS part here. So what is the RHS part? If I take the RHS part, what is RHS? That is A minus B intersection. This is A minus C. So this is our right hand side part. So if I apply the difference formula again as, so what is our difference formula? That is A minus B is equal to, this is A intersection, this is B dash. So if I apply here, this will be A intersection, this is B dash intersection, this is A intersection, this is C dash. So everything, the connectives are intersection. Therefore, A intersection B intersection, this is A intersection C. So here if I write it together, that is A intersection A in one bracket, intersection B intersection C. A intersection A is nothing but A intersection B dash intersection C dash. See, if you observe, the RHS part is again A intersection B intersection C. So this is the LHS part and this is the RHS part. Therefore, from 1 and 2 we can conclude that LHS is equal to RHS. From 1 and 2, so we can conclude that LHS is equal to RHS. So here I can write this as, what is the LHS part? That is A minus, so this is A minus B union C is equal to, this is A minus B intersection, this is A minus C. See here for one more time. See, first of all I have selected the LHS part, that is left hand side, that is A minus B union C. So I have considered this as A and this as B, and I have applied this difference identity, that is A intersection B dash, that is A intersection this B dash. So according to the De Morgan's law, if I want to give this complement to each and every set, this union will turns into intersection, and therefore this is A intersection B complement intersection C complement. And coming to the right hand side, so if I take this, that is A minus B intersection A minus C. So if I take this right hand side, and again I am applying the difference identity, that is A minus B is equal to A intersection B complement, and here also A intersection C complement here. And therefore every connective is intersection, and therefore altogether if I write here, A intersection A is again A, and therefore if you observe this one, this is A intersection B complement intersection C complement, here also A intersection B complement intersection C complement, and therefore from 1 and 2 LHS is equal to RHS, and therefore we got this equation as A minus B union C is equal to A minus B intersection A minus C, and this is our second solution. And therefore our third solution here is, now we have to prove that A union B minus C. See here, A union B minus C should be equal to A union B. So this is A union B minus C minus A. First of all, in order to solve this, see here, that is A union B minus C. And see, there is B minus C here, and therefore I am using the difference identity, that is A minus B is equal to, this is A intersection B complement. If I apply that one, so this will be A union B intersection, this is a C complement, and therefore after applying the distributive law, so if A is distributed to B as well as a C dash, so according to our distributive law, see what happens. According to our distributive law, A is distributed. See here, this will be A union B intersection. This is A union C complement. Clear? And therefore, this can be written as A union B intersection. So, A can be written as A complement whole complement. Union, this is C complement. See here, since we have A complement whole complement is equal to A. So in place of A, I have substituted this one. Clear? And next one here, there are two complements here. I am going to use the De Morgan's law. According to the De Morgan's law, if I want to take this complement outside, see here, A complement union So this is B complement, which is equal to, if I want to bring this complement outside, this union will become intersection. So outside if I keep, so this is A intersection B whole complement is equal to A complement union B complement, and therefore this is A union B intersection. So I'm going to send this complement outside, therefore this will be A complement intersection C whole complement. Clear? And therefore if I interchange and use a commutative law, therefore A union B intersection, so this can be written as C intersection A complement whole complement. See here, according to the commutative law, according to the commutative law, so I can interchange this as A intersection B is equal to B intersection A. So after applying this one here, and see here, if you observe this one, there is an intersection and complement here. So which formula I can apply? I can apply the difference formula as A minus B is equal to A intersection B complement. If you consider this as A intersection B complement, so among these two I can apply the difference formula, that is A union B. So A union B minus, so this one B is C intersection A complement. Again there is an intersection and complement here, and therefore A union B minus. So I can apply the difference formula as a C minus A. Clear? So for every time I'm using this identity, that is difference identity, for too many times, therefore this is so important. Please practice, and definitely you can apply anywhere where we can see the intersection and complement together, and therefore this is A intersection B complement. So this can be written as C minus A, and this is nothing but our RHS part, that is A union B minus C minus A. Therefore we got A union B minus C minus A. From where we have started, A union, see here, A union B minus A. From here we have started, and we got the answer as A union B minus, this is a C minus A. So this is how we have to apply each and every identity, and all the identities I have made a video for you. So those are very, very important, and let's get started with the beginning. See here, back to the beginning, that is A union B minus C. So here there is difference formula B minus C. I wrote B intersection C complement, and after applying the distributive law, A is distributed to B as well as A is distributed to C dash. And if you observe this one, A can be written as A complement whole complement. And the next thing here is there are two complements here. I'm sending these complements outside using the De Morgan's laws, and therefore this union will become intersection. Clear? And next one, so I have applied the commutative law. This is C intersection A complement whole complement. See here, if you observe this one, there is intersection and complement, and therefore if there is intersection and complement, I can use this difference identity. So therefore I have applied the difference identity among these two, that is A union B minus C intersection A dash, and therefore again I have intersection and complement, and therefore again the difference identity I have used, and therefore finally we got A union B minus C is equal to A union B minus C minus A. This is how we have to solve one by one each using all the identities, and if you get the identities thoroughly, definitely you can prove any problem of these kind, and therefore these are very, very important. Don't feel tough. If you get 3 or 4 properties thoroughly, definitely you can solve, and pass it on to your friends if you really like. And don't neglect this video, as these are very important. I have taken from the previous question papers, and definitely it will be very helpful for your for you to get a good score. Thank you so much for watching and staying till the end. Raise your thumb, pass it on to your friends, and look at my next video too, and those are also very, very important. Go through the playlist, pass it on. Thank you so much.